Earlier in the course, we explored Infrastructure as a Service, or IaaS. Now let's explore Google Cloud's IaaS solution, Compute Engine. With Compute Engine, users can create and run virtual machines on Google infrastructure. There are no upfront investments, and thousands of virtual CPUs can run on a system that's designed to be fast and to offer consistent performance. Each virtual machine contains the power and functionality of a full-fledged operating system. This means a virtual machine can be configured much like a physical server by specifying the amount of CPU power and memory needed, the amount and type of storage needed, and the operating system. A virtual machine instance can be created via the Google Cloud Console, which is a web-based tool to manage Google Cloud projects and resources, the Google Cloud CLI, or the Compute Engine API. The instance can run Linux and Windows Server images provided by Google or any customized versions of these images. You can also build and run images of other operating systems and flexibly reconfigure virtual machines. A quick way to get started with Google Cloud is through the Cloud Marketplace, which offers solutions from both Google and third-party vendors. With these solutions, there's no need to manually configure the software, virtual machine instances, storage or network settings, although many of them can be modified before launch if that's required. Most software packages in Cloud Marketplace are available at no additional charge beyond the normal usage fees for Google Cloud resources. Some Cloud Marketplace images charge usage fees, particularly those published by third parties with commercially licensed software, but they all show estimates of their monthly charges before they're launched. At this point, you might be wondering about Compute Engine's pricing and billing structure. For the use of virtual machines, Compute Engine bills by the second with a 1-minute minimum. And sustained use discounts start to apply automatically to virtual machines the longer they run. So, for each VM that runs for more than 25% of a month, Compute Engine automatically applies a discount for every additional minute. Compute Engine also offers committed use discounts. This means that for stable and predictable workloads, a specific amount of vCPUs and memory can be purchased for up to a 57% discount off of normal prices, in return for committing to a usage term of 1 year or 3 years. And then there are preemptible and spot VMs. Let's say you have a workload that doesn't require a human to sit and wait for it to finish, such as a batch job analyzing a large dataset. You can save money, in some cases up to 90%, by choosing preemptible or spot VMs to run the job. A preemptible or spot VM is different from an ordinary Compute Engine VM in only one respect. Compute Engine has permission to terminate a job if its resources are needed elsewhere. Although savings are possible with preemptible or spot VMs, you'll need to ensure that your job can be stopped and restarted. Spot VMs differ from preemptible VMs by offering more features. For example, preemptible VMs can only run for up to 24 hours at a time, but spot VMs don't have a maximum runtime. However, the pricing is currently the same for both. In terms of storage, Compute Engine doesn't require a particular option or machine type to get high throughput between processing and persistent disks. That's the default, and it comes to you at no extra cost. And finally, you'll only pay for what you need with custom machine types. Compute Engine lets you choose the machine properties of your instances, like the number of virtual CPUs and the amount of memory, by using a set of predefined machine types or by creating your own custom machine types. As we've just seen, with Compute Engine, you can choose the most appropriate machine properties for your instances, like the number of virtual CPUs and the amount of memory, by using a set of predefined machine types or by creating custom machine types. To do this, Compute Engine has a feature called autoscaling, where VMs can be added to or subtracted from an application based on load metrics. The other part of making that work is balancing the incoming traffic among the VMs. Google's Virtual Private Cloud, VPC, supports several different kinds of load balancing, which we'll explore shortly. With Compute Engine, you can in fact configure very large VMs, which are great for workloads such as in-memory databases and CPU-intensive analytics. But most Google Cloud customers start off with scaling out and not up. The maximum number of CPUs per VM is tied to its machine family, and is also constrained by the quota available to the user, which is zone dependent. Specifications for currently available VM machine types can be found at cloud.google.com/compute/docs/machine-types. Now let's explore some of the most important virtual private cloud compatibility features. Much like physical networks, VPCs have routing tables. VPC routing tables are built in, so you don't have to provision or manage a router. They're used to forward traffic from one instance to another within the same network, across subnetworks, or even between Google Cloud zones, without requiring an external IP address. Another thing you don't have to provision or manage for Google Cloud is a firewall. VPCs provide a global distributed firewall, which can be controlled to restrict access to instances through both incoming and outgoing traffic. Firewall rules can be defined through network tags on compute engine instances, which is really convenient. For example, you can tag all your web servers with, say, web, and write a firewall rule saying that traffic on ports 80 or 443 is allowed into all VMs with the web tag, no matter what their IP address happens to be. You'll remember that VPCs belong to Google Cloud projects. But what if your company has several Google Cloud projects, and the VPCs need to talk to each other? With VPC peering, a relationship between two VPCs can be established to exchange traffic. Alternatively, to use the full power of Identity Access Management, IAM, to control who and what in one project can interact with a VPC in another, you can configure a shared VPC.